Okay, this is a continuation of the 2008 non-calculator NAPLAN paper, question 9. We've got two squares, A, B, C, D, and square MNPQ, and they're shown there. And we need to compare the area of ABCD with the area of MNPQ. Okay, now we know that the square ABCD is smaller than the square MNPQ, so we can automatically, so the area of ABCD has to be smaller, so it can't be twice the area, so that answer's wrong. And it can't be 4 times the area. So we've got two choices here. Is ABCD half the area or a quarter of the area? Well, let's just have a look. What I'm going to do, I'm going to put some lines through here, just keep dividing the shape up. Now I can see that this area here is the same as this area there. So I'm going to call these both 1. I can see that this area over here is the same as that there, area 2. This area, this triangle here is the same as that one there, area 3. And then I'm going to keep the last 2 blank. So I can see that the square in the middle is made up of 1, 2, 3, 4. And the whole shape, the whole large square, has got 2 1s, 2 2s, 2 3s, and 2 4s. Now that means that the large square is double the size of the small square. So large square is double the size or twice the area of the small one, or we can say the small one is half the area of the large one. So the answer is going to be the first response here, that the area of ABCD is half the area. Now you've got to be really careful. A lot of people could get confused between the first and the second answer, which is probably a good idea to read through it first, cross off the ones you know don't make sense, and then go back and try and finish and do the question. Okay, now for question 10. There are 50 marbles in a bag. 10 marbles are red and the others are all black. Emma picks a marble from the bag without looking, so I'm just going to do a little bag. Got 50 altogether. I've got 10 red and the others are black, so there must be 40 black. In total, we've got 10 plus 40 is 50 in total. So Emma picks a marble from the bag without looking. The chance of her picking a red marble, well, red is 10 out of 50, and then we simplify that, and we get, so we can write 10 out of 50 or 10 over 50. You simplify that, dividing both the numerator and the denominator by 10, you get a 1 in 5 chance. Now, notice that's not one of the responses, but if I double the 1 and the 5, if I times them both by 2, I get a 2 in 10 chance. So 1 in 5 is the same equivalent fraction as 2 over 10 by multiplying both the numerator and the denominator by 2. Now that's one way you can do it. The other thing you might do is you can eliminate some of the solutions. So you know you've got 10 red and 40 black, so you've got 10 out of 50. If it was a 5 in 10 chance, that's half, so you know that's definitely not right. 4 in 10 just seems like too many, because it's just under a half, and 10 out of 50 is a lot less than a half, so that one's not right. This is like a mathematical way of doing it. But, you know, if you're a little bit confused or finding it a bit difficult, you could eliminate some as well. Like you've got 1 in 10 here. If you've actually got 10 red, that's like saying 10 in 100, and that's definitely not correct because you've got 10 out of 50. With this one, the answer is 2 in 10. Well, you've got 10 red. That's like saying 2 times 5 is 10, and 10 times 5 is 50. Well, that's 10 out of 50, and that is what you've got. So there are a few ways of doing that question. Now for question 11. ABCD is a square. We've got ABCD, it's a square. A square means that all sides are equal. And what we're asked here is to find the value of x. There are a few ways you can do it. You can do it by solving the equation. That's one way of doing it. The other way is to substitute these values of x into both of those and see which one gives you the same answer. So I'm going to do it by substituting first. Now when you've got 4 numbers like that, I wouldn't go for the smallest or the largest. Try 2 or 3. Otherwise, if you start here and the answer's actually up there, by the time you work all your way up there, it's going to take a long time. So I'm going to try, let's say x is 2. So for this side here, I get x plus 1 is 2 plus 1, which is 3. And for this side here, I get 3 times 2 minus 5. Well, that's 3 times 2 is 6. Take away 5 is 1. Well, that doesn't work. So it's not x is 2. I can try x is 3. So if I put 3 in here, I get x plus 1 is 3 plus 1, which is 4. And on this other side, I get 3 times 3 minus 5. So 3 times 3 is 9. Take away 5 is 4. Now those two answers are the same. So my answer must be x equals 3. Now that's doing it by guess and check. The other way to do this question is to solve the equation straight off. Now, because we know that all sides of a square are equal, we can say that this 3x minus 5, whatever it is, has to equal x plus 1, and we can solve the equation. So putting our pronumerals, anything with x's on the left and numbers on the right, we get 3x take away x equals 1 plus 5. Now 3x take away x is 2x, and that equals 1 plus 5, which is 6. Dividing by 2, we get x equals 3. So that's another way that you could have worked out that answer. And so for those that are very confident in setting up the equation and solving it, you would do it that way. And for those that would struggle with doing that, you could try this way, just try the different answers. Here we've got 5 students compared their heights. This diagram shows their results. Now, that symbol with the arrow means is taller than. So we say Anna is taller than Belle. Belle is taller than Eva. Belle is taller than Con. Con is taller than Eva. And Con is taller than David. Okay? So Con is obviously taller than David and Eva. But Belle is taller than Eva and Con. And Anna is taller than Belle. So therefore the student that's the tallest would be Anna. Okay, now for question 13. Which of the following expressions is equivalent to 2 bracket 5m plus 1? So what we need to do, we need to multiply the 2 by the 5m, and we get 10 times 10m. So 2 times 5m is 10m, and they're both positive, so that's positive, plus we get 2 times 1 is 2. Now 2 is positive, 1 is positive, so we've got a plus. So 2 times 1 is 2. So therefore the expression that's equivalent to 2 lots of 5m plus 1 is 10m plus 2. The other way that you can do this, if you struggle with that, is you've got 2 lots of 5m plus 1. So we've got 5m plus 1 plus another 5m plus 1. So therefore, looking at these together, we've got 10m, and looking at just the ones together, we've got plus 2. So that's another way you could do that and get 10m plus 2. Now for question 14. Which fraction has the same value as 2 3/4? Now, one way of doing it, for those that know how to do it quickly, we've got 2 full, you can think of this as 2 full circles and 3/4 of a circle. So each of these 2 circles is cut up into 4s. So we've got 4 times 2 is 8. 8/4 plus another 3 gives me 11/4. That is the solution, 11 over 4. Some students find this hard to do, so what you might want to do, you might want to draw it. I've got 2 full circles and I've got 3/4 of a circle. Now because I'm working in quarters, because one of the circles is in quarters, like this last one, you need to put them all into quarters. And let's just shade what we've got. We've got 1, 2, 3, 1 full circle, 2 full circles, and 3/4 of a circle. So these are all cut into quarters. Let's count the quarters. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 quarters. And we write that as 11 over 4. 15. Here is a standard die. Now with all die, the sum of the dots on opposite faces is 7. So for example, if there are 3 dots on top here, then underneath, the one that we can't see, that face we can't see, should have 4 dots. If there are 2 dots here at the front, then at the back, and we can't see that, there should be 5 dots, because 2 plus 5 is 7. And if there are 6 dots over here, then the face on the left in there that you can't see should have 1 dot. So if you look at how you could unwrap and do the net of a die, this face here would be opposite this one there, because you start here, go over another face, and down on the other side will be the other face. So we need to look at, say, those two, and we notice that 1 plus 4 equals 5. It doesn't equal 7, so it's not this one. Let's just do the ones that are easier to look at. I don't want to look at this one first, okay? Oh, actually, I can look at this one, because 1 and 5, just those two, make 6. So it can't be that one. Let's look at these two. They would be opposite faces. 5 and 6 makes 11. So that added up to 5. That's no good. This adds up to 6. That's no good. Those two add up to 11. That's no good. And let's look at these two. 5 plus 2 is 7. Now look, there are some other faces that add up to 7, like this one, 2 and 5, but these two don't, so that won't work. Okay? You know, this face would move in there. 6 and 1 is 7, and also here 3 and 4 is 7. So it's definitely this last one. Okay? You could also see on some of the others, that one, 4 and 1 makes 5, that wouldn't work. And here, 6 and 2 makes 8, that wouldn't work as well. But you just need to find one combination that doesn't work, and then you can say, well, no, it's definitely not that die. Okay? Question 16. What is the size of the angle in the shaded triangle? So this angle here. Now notice it's an obtuse angle, so we need an angle that is bigger than 90 and smaller than 180. Now notice this scale on the inside starts at 180 and goes down, so we don't use that scale. We need to use this outside scale that starts at 0. So we're up to 90 so far. We keep going, 100, 110, 120. Now it looks, there's 130, and your two like intervals or dashes away from 130, and it's before 130. So that angle would be 128 degrees. Question 17 says Mark made this solid object using 36 cubes. He then painted the complete surface area of the object grey. So it's painted grey all around the outside, and he then broke the object up into 36 cubes. So he broke up all the cubes. And the question is, how many cubes have no grey faces? Now, if you look at the top layer of cubes, they all have a grey face on them. Some of them more than one grey face. This layer here also, this side layer, so these 9 cubes over here on the side, they also have some grey on them. These 9 cubes here at the front, there, or on the side you might call it, also have grey faces. Same with those 9 cubes on the end, they'll all have grey faces, and these 9 cubes looking back this way, they'll all have grey bits. Now, if you look at what I'm going to say, the top layer definitely has all grey, and so the bottom layer also definitely has all grey. Now I'm going to draw out the middle layer. The middle layer is like this. Now all these outside ones have grey, but this one in the middle does not have any grey faces on it. So that's in that layer there, that second layer. Same with the third layer down as well. All the outside ones would have been painted grey, but there's this middle one in the middle that does not have any grey on it. So if the object was broken up into 36 cubes, there would only be 2 cubes. Those two in the middle. One there, and there's your second one there, and they're right in the middle of the cube. So 2 cubes would have no grey faces. Okay, that's the end of this video. We'll start question 15 in the next video.